Good morning, this is Greg Sykes from Greg Enterprises. I wanted to review some stuff that we're doing on our blog. We're doing a scenario and preparing for the subnetting quiz that was scheduled yesterday that's been delayed till next week. We were referring this quiz to some information that I had put on our blog, and it was a direct referral to the videos that I also posted for Jeremy's video on subnetting. Now, this particular video was going over a subnetting example. He was trying to subnet 5 networks, and he went over the routine on how this was done. Now, what we're going to do is we're going to go over this in detail, probably sometime next week on our blog. And what I'm trying to show you here in this video is how those addresses can be applied to a real network. In this scenario, we're using a simulator called Cisco Packet Tracer, and we're going to take this simulator and try to apply those addresses. Well, we're actually going to apply those addresses to these routers, as you can see here. Those addresses are the subnetted addresses, the ranges from the video that we will be working with. Now, we can take this to another level. I posted a blog on the CLN network, the Cisco Learning Network, a while ago, showing you how you can use those addresses, and then you can actually take those addresses and bring them to route using a routing protocol such as RIP or EIGRP or OSPF. But in this scenario, we're going to show you on a more advanced level how this works in the real world. Now, this was a different network. This was a 150 network, a Class B network, and we took it and applied those addresses from those routers by looking at the show IP route that I'm showing you now, which was which you just seen on the screen there. The R indicates RIP, the C indicates directly connected networks, and you're going to somehow be able to do this yourself. I wanted to show you in a backdoor way on how I and most of the members learn through practical learning. For me, would be to apply this to a topology, to study the theory behind it, and to be able to understand through problem, cause and effect, because it may not always work, and then be able to blog it and use several other mediums, as you can see on this blog, which I will post on our network, on our on Greg Enterprises on Skype. I'll post this link, and you will run into problems sometimes, but you have to be able to kind of follow up, because if there's a problem, there's a solution. There's always a solution. You don't want to hit a wall and then say, okay, I'm done with that. I use the CLN network a lot to also answer questions, and it has a ranking on that network where, if you like, Keith Barker's on the network. He's like a double platinum VIP member, which he answers questions all the time, and that's why he's a platinum member, because he's constantly answering questions. So getting back to this topology, we're showing you that this corporate router right now only has RIP on it. And what we're going to do, what the goal is with this, is I wanted to kind of advance to routing and then take you back through subnetting. So this, you have a general idea on how eventually this is what's you where it's going to go. You have to know how to subnet. Definitely have to know how to subnet. And from subnetting, you can actually look at this. We're doing a show IP protocol right now to see what's the routing protocols on there. What routing protocols is on the subnetting, and you can actually see it's showing you the what's on there through the show IP protocol command. I'm working with Carlos right now.
Yeah. Default 10 seconds for hello, then conversion should probably happen relatively quickly if everything matches on interfaces. So maybe do a show IP protocol to see if the protocol is actually running. Now we should see an entry for OSPF if it was, and I do not see it. I only see routing protocol RIP. Okay. Well, first you need to create an OSPF process. I would start with one router. Just keep it simple. Let's just start with this top one. We see RIP's already running, so let's see. Not show. Need to be in config mode. Router, OSPF, and we're going to choose a process ID number. It's unique to each router. It does not need to be shared amongst routers. So then we need to tell it what interfaces is going to actually send OSPF packets out of. And I'm just saying this because it's like good practice. So I think you do passive interface default, which it'll basically say all the interfaces are passive and will not send OSPF packets. So we want to choose which ones will not be passive and will send OSPF hellos, which should be the router facing interfaces. So here we have router at the top. To the left you see serial 001 and serial 000. Those should be not passive, so we'll say not passive interface, SE0/0/1, no passive interface, SE000. That will stop hellos from being sent out the FA00 toward the PC because it's not needed. So then we need to tell it what networks it's going to advertise, and it needs to know about 150.10.4.0.24, also the 1.0 and the 2.0. So we'll do. It only has 3 interfaces and it's only in 3 networks, so it should learn the 3.0 from the other routers since they're connected to it. So we only need to tell it to tell the others about the networks it's connected to. So network 150.10.4.0, and I believe this is reverse subnet mask. So I don't know the best way to explain that except, yeah, but I'm just trying to explain it. Like, so normally you'd have a subnet mask for a /24 being the first three octets set to 255. This is called a wildcard bit mask, which is basically inverse mask. So you would set it opposite of it. It's just to keep it simple. That's that. So, and we're gonna treat this as a single area. So you always want to have area 0 as your first, your backbone. Um, so we're gonna set that. We're gonna basically use this for all of them. So just moving on. We'll get in the next one here. Yeah. And you can do it that way too. So let's see, what else do we need here? It's advertising that network. I'm not sure. I never did a mix yet, but I guess we'll see what happens. Yeah, we can do that. Well, I mean, the only reason I've seen to use RIP in combination with OSPF is you would put it on a what's called an ASBR. So, like in a stub zone, you might have a router on the outside of an area facing, a RIP connection. So you would have an autonomous system border router that would be kind of an intermediary to translate it to OSPF, and it could redistribute routes from the RIP without getting into LSAs and how OSPF does that. But that's the only reason I've seen. I mean, I know there might be some crazy labs out there where you can do it together. I haven't seen a reason for it. So, EIGRP routes. No, no. So that one probably has ERGRP running. So also it'll probably work because the way um also I remember this now. What exactly? So you'll see like a value slash a number, right? Right. It's sending out hellos and it doesn't see anything, so it's just gonna send out hellos for its default timer of 10 seconds. So um I just want to say that it probably would work because even though these different routing protocols are going over, they have what's called an administrative distance. So the routing table is looked at, and there's different factors taken in, and RIP's administrative distance is 120. As you can see here, like it says R, and you see this first before the slash says 120. Whereas OSPF is 110. So an OSPF route, since it's a lower administrative distance, is going to be followed before a RIP one is. So if we do OSPF for the same routes on RIP, it's going to take the OSPF route. Unless you adjust the administrative distance manually. So that's how you could have multiple. And you may, I guess, have it in case you did have some hardware that for some reason couldn't speak an open protocol and only speak some really old stuff like RIP. But it's a little delayed for me. No, it's a little delayed. Let's see. IP. So now we just need our network. So this one is in 150.10.2.0. Did I put the third net? Yeah, I think I put the third network on the other one, right? Area 0. And then we also have 6 and we have 3. Well, you see the adjacency come up on that one. And that's the last 2 states right there that it's showing is from loading to full. So let's see. Let's do 6. Three. So you see designated with O, and like I said, administrative distance default is, yeah. Yes. I mean, also this doesn't have to be like totally different sites. Depending on this could be buildings, this could be floors, depending on how much you want to break up the broadcast. I mean, so let's see. This is not really needed, but I like to do it for practice. Yeah, that's it. Yeah. I think we have like a MPLS circuit, but probably off the router going through AT&T is probably a serial or something. That's not right. That's right. Okay. So now we have the network. Let's see the adjacency come up for this one. Dang. Typos. So we should see it for this guy. Put them in the same area. Give it 10 seconds. Did I type that wrong? I did type it wrong. I put 1 instead of 10. Yeah, let's just watch your typos. All right. There we go, and you see the next adjacent coming up from I mean, we could also do these with static, but it makes it really nice that it's gonna propagate them all. Yeah, yeah. I mean, and like, and I think on the higher level stuff, they don't even let you use static routing because you could use static routing to fix everything. You just a subnet mask for what you need and say where you want it to go, and then it gets really hard to follow. So you see now the adjacency is built from each side. Um, so each of these routers should only have the 3 networks that we put on them as directly connected, and then for the O entries, we'll should see the other ones that they're not touching. So to do that, we'll do show router IP route, show IP route. Do. So here we should only have directly connected 5, 1, and 3. So for C we have 5, 1, and 3. But you'll see for O it learned from its adjacent routers the other networks like 2, 6, and 4. So we have 1, 2, 3, 4, 5, 6. So if these guys are configured with IP in that subnet, which we'll have to check they're not, we can give them a address in this network that they're in. So did we even give an IP to these interfaces? All right, so that's already configured for us. So we're using .2. So we could use .1 here on the host, anywhere within this range. So yeah, normally, I mean, we usually reserve like at least the first 10, but different businesses and processes may have different reasons. Some people like to put it at the last IP address. I don't like that. But anyway, it could be any IP in there. Just document it and try to make it consistent. PC0. So this is in that 5 network. So I'm just going to give it 3. It's that's not our subnet mask. It's a 24. So your IP address and mask have to match for the network ID to match. And so our gateway needs to be this interface, and it was set to .2. So because whenever it can't reach an IP address in this network, it goes to the gateway. So it needs to go to this router for it to compare to this router table to find out which port to send it out to get there. All right, I think that one's good. Let's just close that for now. I'm gonna assume the other ones are .2. I mean, it's labeled on there. Is that correct, or? Okay. I guess we'll find out. Well, did I assign .2 by accident? .3 is being used on this side. Let's check the configuration on this guy. So, show serial interface 6. Okay, so 3 is already being used for this router. So it wasn't .2, it's .3. I guess I should have saw that, but it looked kind of cut off on my screen. I see .3 on that side on the All right, so we'll give this .2, and hopefully it's not confusing that the gateways aren't. But that interface on that router S1, its FA00 is 150.10.6.3. So that should be our gateway. That's where we need to send. Because normally you would have like probably a switch between these hosts. Oh, is that a straight cable or a crossover here? Because I mean, it's like device. The dotted one is crossover, right? Yeah. So right. So I mean, and what really just makes it a like device is what pins it decides to send and transmit on. Um, and since a switch is normally switching between two, they're opposite. So let's see. I just want to test the ping to the first one. Just to make sure. And we said that other host was .3. I guess we'll get an ARP. Or maybe not. So there's the ARP, and so I mean what it did was it did a broadcast because the computer itself said it looked in its ARP table for this IP address and didn't have anything. So it did ARP requests and got a response for the MAC address to populate it. But it didn't need to because it got to layer 3 routed interface and received it probably from the client itself. Anyway, so that's working so far, so we just need to configure this guy. Let's 120. 120. 110. Yes. You gotta. You need. I think you need to review your Rainbow Robots story. Don't worry, kids. Robots aren't real. Oh wait, they are. All right. So this interface is .1 on this one. So it's good to always check. You know, you can be sure, but just always verify configuration. And personally, I mean, if this was like real life, I'd probably change them to all be consistent. But this is good practice for making sure you know what the routed interface is. So let's go back to this machine. So now we should be able to ping all around, right? So let's see if I can remember all these guys' IP addresses. So we were pinging 3 in the lower left corner. So he's got a reply. And we should have, is it 6.2? Got a reply. So he can reach all these. And I'm pretty sure they can reach each other, but I mean, we've already pinged across here. And this one can go this way, so I think we're pretty good. We can go look at the routing tables again just to review. and we'll see that we're indeed getting the directly connected interfaces, the .1, .4, .2, listed with a C in front of it, .1, .2, 4, and the rest, 3, 5, and 6, are learned from OSPF. So, I mean, I really also like the show IP protocol. It gives you some more information. I think there's even a. So this will tell you what's running, when's last updates, which networks it's and which areas it's in. So, and the router ID. So, I mean, there's some more stuff we can go into the protocol, but I don't think. Yeah. Yep. Yep. Yeah, you can turn off all, or you can just do POS. Yeah. I think you might have to. Um, might be a particular process. I mean, you could do events too, but so here for the events, you'll see the hellos, whereas their adjacencies are already fully loaded, so we probably won't see those. But what we could do is take down an interface and see the adjacency come up, but not really. But it's, I think, pretty much a similar process where you would issue, a router command and establish a network. They think they do have autonomous system numbers, so that I think process has to be shared. I'm not sure amongst routers. But do they all need to share that 100, like a channel? I believe, yeah. So that's where, I mean, that's one of the places it differs. Um, OSPF is also a link state based, so like its routing tables don't change unless the topology or the interface changes. Whereas RIP, it's measuring the hop count and it changes, I guess, as like with each travel. So. So I mean, I guess we could use subnetting to relieve some of our address space, if we wanted to. But we could take that /24 that we were using in the example you have up there, and we could break it down if you. Yeah. Well, so right. I mean, their topology there isn't a full ring, but um, so if we did like a static route, we'd probably need to set a default route or a gateway of last resort for not the hub router, but the outside router. So, well, he's on the same side as the router too. So if he's on the same LAN segment, and they were, yeah, they could have a static route for that network. Um, they would probably want to split up the network because if you started to say like a /24 out of every interface, you're gonna have an issue. So right, +3, so 27. Mhm. Yeah, 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 yeah. Well, I mean, depends on your needs. I mean, some instances 24s work fine. The purpose of subnetting is you need to split up the networks to, make your broadcast smaller, to where you can control which one networks are talking to each other. Um, so you should never actually make a network larger than a /24. Like or have that many hosts in the same sub network, from what I have been told as best practice, because you just get a lot of, you could get possibly get a lot of broadcast traffic. So I think actually, like, if they could get subnetting and maybe get exposed to VLSM, or variable length subnet mask, and all that refers to, and that was kind of tricky for me at first too, to think about, like, even when you think you understand it, but you have to start with the lowest number of the CIDR and do your subnetting, and then start with the next available range and do another subnet with the new CIDR, which would be a larger CIDR number but a smaller divisions, to where you have your /30s at the end, so that you could use your /30s for your routers. Um, and really, in the real world, what works best is if you look at, and this is for reference, RFC 1918, there are IP addresses that you would use on the inside of your network behind your main router that do not route, that are instantly dropped. So you're able to use that within your site. You know, to further divide the space and give you enough organization for printer networks, server networks. Even in just the um, like a 10 network, but you could make it whatever slash you want. So a lot of times we do have a lot of /24s for like when we're doing a DHCP off of an AP at a particular location, because we don't want more than 240 or whatever, or maybe we'll make it even smaller if we don't want a lot of wireless traffic coming from out there. So it's just things to consider when designing. And yeah, I think if it's all staying on VLAN 1, that'll be fine without having to configure any trunking. If we stay in the same VLAN. So that should be fine if this switches connect to the routers. So but they're starting off with a /24. So I mean, well, after the, you can put it after networker. That's fine. So I mean, a /24, that's one network. So we need 5 networks. Now, the only thing is, I think they had 5 networks in the example because the routers in the example weren't fully meshed. Yeah, you see how AZ is not connected to Florida? In our example, we have a triangle or mesh topology, like it's fully meshed. So like the example is 5 because you have 2 networks between 3 routers plus the 3 networks for the switches on the outside, which is 5. In our example, we would have 6 networks. So either we could get rid of the connection between. Yeah, we can adjust it and do 6 networks. Yep, exactly. Right. The increment will be 16. The new mask will be 240. No, no, that's not correct. Okay, so we need 6 networks. We need 6 subnetworks. So how many network bits do we need? But that's only going to give us 2 to the power 2 subnetworks. See, so, okay, the subnet mask is going to stay the same. Because we need 5 networks in this example. So we have 2, 4, 8. So 5 is greater than 4, so it falls in 8, right? And 6 also falls in 8. So it uses the same number of network bits. So the mask will stay the same. So they just didn't, we'll have more networks. We'll have the exact same scheme. Except there's actually 8 available networks in this example. If you count the increment here, 1, 2, 3, 4, 5, 32, increment by 32. If we kept incrementing 96 until the end, we should end up with 8 subnetworks. Yeah. But I was just saying, I didn't know if you wanted to mock the example or did you want to keep the mesh. If you want to keep the mesh, then yeah, that's why I think this will still work. Like, I was just checking to make sure that we didn't need to move our network bit, which we don't because yes, they'll have 8 subnets available, so it's fine. But so yeah, yeah. What's the interface? Do you already have the clock set on this, or is it defaulted? Okay. Well, we should probably do that first. Yeah. So I just wanted to point out that like whether you have 5 networks in this scenario or up to 8 networks, this subnet mask works. So, and they're drawing in the bottom right, they're only showing that they're going to use 5 networks, but I guess in our example, we're going to use 6 networks. Yeah, 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 yeah. And I'd say in a real life scenario, though, what you might do is use like /30 on your routers, unless it's like a point to point network. Then you might use even a higher CIDR. Because, I don't want to get into that because it might be confusing too, but you want to conserve your address space. Um, you can use like a totally different numbering scheme in CIDR, that for just your routers, those IPs that you're buying, you know. But on the inside, on the outside, on the other side of your router, and inside, you can use, the RFC 1918 to give you more space. It's easier to expand rather than buying like a whole C block of a routed IP address. So I think maybe you should probably split it here. I'm just Yeah, okay. Yeah, 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 So yeah, I mean, virus protection's kind of like the flu shot anyway. So that too. I mean, most of them are getting distributed copies, probably for some Russian hacker with a backdoor in it. So as soon as you hook up a loopback interface to your machine, or even probably run the iOS in your CPU stack, you're probably open to anything. So yeah, yep, yeah, yeah. I mean, we're using emulated software. You're gonna